Okay, I think we're live. If there's anybody out there, maybe you can let me know. And in the chat. Oh, hey, Silo. Bacon, welcome, Bacon. It's funny seeing you guys here. Okay, so current plan is just, first of all, to mute myself. Okay, current plan is just to keep going, I guess, right? So I think I finished 2.4 yesterday or day before yesterday. I didn't do one yesterday, right? And then, or was that yesterday? I don't remember. We'll do 2.5 today. Hey Astro, welcome. Um, so let me SSH in to the code space. Make this bigger. Cool, we're good. I really need to figure out these neovim errors. Yeah, last time we done this. And cool. All right, working with data, endianness. I'm assuming that's how you say that. Let's try to output a value stored in memory using the function we just wrote. We're going to do it in two different ways. First, we'll enumerate all its bytes separately, and then we will type it as usual. Okay. I'm gonna make a new endianness diasm. Section data demo 1 DQ. What's DQ? This is new. Due to that. I want to turn off Copilot. There we go. Okay. Not demo 1. Demo 1. Okay. Demo 2 is DB, which I am more familiar with. 11, OX22, OX33, OX44, OX55, OX66, and so on. Okay. Section text start move RDI demo 1, and then do I need to copy over these functions? Like that. Okay, and then endianness. The significance of the end of the byte stream. Okay. Call print x and then call print new line. If the end has large significance, then it's called big endian. Significance in what sense? Like significant to who? I'm not sure I totally get it. Move RDI demo 2 and then print x, call print new line. And then we're gonna exit. 60 XOR RDI syscall. All right, and I was told by you guys to comment my code, right? So, this like moves demo1 into RDI and prints it with a new line, right? And this like does the same thing, but for demo2. And this is just to exit. Significance as in how large the value of the digit represents. Okay. That makes a little more sense. Terminal. Did I make those just commands? I did, didn't I? Okay, so I'm gonna just run endianness. Maybe I didn't make those just commands. Oh, that was locally I made that. Okay, so I need to like do my NASM dance. NASM. This guy. What did I call it? Endianness. Okay. Endianness. And then endianness. Uh-oh. We got problems. We've got problems. Oh, good, an example. Okay. Okay. Gotcha, that makes sense. I'm having all sorts of problems with this. Okay. Symbol new line char is undefined. Where am I even? New line char? Oh. I think I needed this. I go in here. Alright, let's try that again. Symbol codes is undefined. Okay. Symbol codes, because I'm referencing codes in here. Wait, so of course this isn't working because codes is referenced in here and codes doesn't exist. But what do I... Oh, I do need codes. Okay, I do need codes. Because that's just the reference for how hex works. Okay. Now... Okay, that kind of worked. And then we need to link it, right? This guy. Endianness. And endianness. Cannot find entry symbol start. Do I need to do like the global start dance? Should I do that here? Oh yeah, this guy? That's probably what's missing. I don't know where to stick him. Maybe at the top? Or I don't know. I don't know if it matters. We'll find out. Compile it again. Link it again. Oh, it worked. So now we have this guy. Sure enough, we got the exact same output as he did. Cool. Now can I go back and try to really understand what's happening? Yes, I do not know what global does. I get it. So it like exposes whatever label you point it to as like the entry point. It's kind of what I get. Um, Multi-byte numbers are stored in reverse order. Oh, so that's your point. Is that these end up being stored like backwards. Yep, okay, cool. Okay, that does make sense. The bits, well, I don't, what's DQ doing? The bits in each byte are stored in a straightforward way. Did the stream pause? Is the stream paused? Still going for bacon? Right. Most of you are good except for Silo, so maybe it's on Silo's end. Let me know if it keeps not working. Oh, the cement eating cat is here. Awesome. Okay. Um, the bit the bits in each byte are stored in a straightforward way, but the bytes are stored from the least significant to the most significant. Hello, Riley plays random stuff. This applies only to memory operations and registers. The bytes are stored in a natural way. Different processors have different conventions on how the bytes are stored. Big endian multi-byte numbers are stored in memory starting with the most significant bytes. Okay. And then little endian multi-byte numbers are stored in memory starting with the least significant bytes. That's exactly what you guys told me. Cement. As the example shows, Intel 64 is following the little endian convention. In general, choosing one convention over the other is a matter of choice made by hardware engineers. These conventions do not concern arrays and strings. However, if each character is encoded using 2 bytes rather than just 1, those bytes will be stored in reverse order. Okay. That's interesting. Doesn't, like how many bytes does one UTF-8 char take up? If you wanted 4 bytes. Okay, so if you had an array of UTF-8 chars, they'd be in order, like in the natural order, but each individual char would be stored backwards. If it was little endian, right? The advantage of little endian is that we can discard the most significant bytes, effectively converting the number from a wider format to a narrower one, like 8 bytes. Okay. For example, demo 3, DQOX1234. Let's try it. Demo 3, DQ Dairy Queen OX1234. Big endian is normal. It's stored how you would read it. Okay, yeah. But little endian is more used. Cool. I'm supposing for this reason. For example, demo 3, Dairy Queen OX1234. Then to convert this number into DDub. Oh, DQ was like the because there's the DDub and the DQ and the DB, right? What did the Q stand for? It's like quarter or something. In ASM, what do DDub, DB, DQ stand for? Dairy Queen. Define byte. Yes, define word, different quad word. That's what it was, which is 8 bytes. So a word is 2 bytes. A quad word is 8 bytes. What if we went 4 bytes? What's 4 bytes? A double word. So is it DDub? Oh no, that's DDub is define word. Wait, so how do we do? but is there an equivalent of ddub or dq for it? That's dd. Oh, defined double word. Okay, cool. All right, so that makes sense. So then when we printed it out, the one that's backwards is the second one, which is this one. Okay, yeah. The advantage of little endian. Yeah, we did that. Okay. To convert this number into ddub, we have to read the word number starting at the same address, demo 3. See table 2.1 for a complete memory layout. Okay, here's table 2.1. Here's demo 3. Like LE and value B. What's LE and BE? LE and BE. I have no idea. No idea. Chat. What's LE and BE? I got questions. What's LE and BE in the context of assembly? x64. Oops. Oops. I just lost it. Okay, hold on. In the context. Oh, little endian is BE and is little endian. Okay, LE is little endian and BE is big endian. Oh, perfect. Okay. That makes sense. Demo 3, which was this guy, OX1234. And little endian becomes OX34. Wait. Why? Because it's the little end. But oh, this is the address. Okay. This makes sense. Okay, yeah. Why it is OX00 though? Oh, probably because this is actually like this. No? Is that why? I think so. That would make sense. And that would make sense why we start getting to 1, 2 finally after like all these, after you get 6 bytes into it, right? That makes sense. Okay, yeah. Okay, this is actually cool. So all it's saying is that if you have something like this, then little endian would start over here and then work this way, whereas big endian starts over here and works this way, right? Cool. Big endian is a native format often used inside network packets, TCP/IP. It is also an internal number format for the JVM. Okay. Middle endian is not very well. No, that sounds really confusing. Middle endian. Assuming we want to create a set of routines to perform arithmetic with 128-bit numbers, then the bytes can be stored as follow. The first will be the 8 least significant bytes in reversed order, and then the 8 most significant bytes also in reversed order. Wait, 8 least bytes in reversed order, and then the 8 most in reversed order. So it's like 7 down to 0, and then 16 down to 8. I don't understand when this would ever be useful, but I mean, I see how it's a valid format, I suppose. Strings. As we already know, the characters are encoded using the ASCII table. A code is assigned to each character. A string is obviously a sequence of character codes. However, it does not say anything about how to determine its length. Strings start with their explicit length. Anything about how to determine its length. Strings start with their explicit length. And this is a convention, I'm assuming? Because there's nothing forcing me to do this, right? Because before we had something like this, but without that, I think. A special character denotes the string ending. Traditionally, the 0 code is used. So these are just null terminated strings, which I think are in C too, right? You've never heard of middle endian. So I guess it's at least not very popular. All right, constant pre-computation. It is not uncommon to see such code, db0 later. Okay. NASM supports arithmetic expressions with parentheses and bit operations. Such expressions can only include constants known to the compiler. This way, it can pre-compute all such expressions and insert the computation results as constant numbers in executable code. So, such expressions are not calculated at runtime. Okay. A runtime analog would need to use such instructions as add or mul. Okay. Pointers and different addressing types. Pointers are addresses of memory cells. They can be stored in memory or in registers. The pointer size is 8 bytes. Data usually occupies several memory cells, i.e. several consecutive addresses. The pointers hold no information about the pointed data length. Wait. Yeah. When trying to write somewhere a value whose size is not specified and cannot be deduced, for example, move into there 4, we can get compilation errors. In such cases, we have to provide size explicitly as shown below. Oh, that's interesting. Just write byte or word or dub word or q word. What is test equal to after each of the commands listed previously? Test is -1. I would first have to know how -1 is expressed in binary. I'm not very good with negative numbers. How is -1 expressed in binary? Oh yeah, it's the whole 2's complement notation. This pattern is here. Can you explain the 2's complement? It's a method for representing signed integers in binary, allowing for both positive and negative numbers. Here's how it works. Positive numbers. Positive integers are expressed as usual in binary. For example, the number 5 in an 8-bit system is represented as that. Negative numbers. To represent a negative number, follow these steps. Write the absolute value in binary. Start with the binary representation of the absolute value of the number, for example. Okay. And then why is this like a code thing now? Oh dear. This is horrible. Invert the digits. Invert the digits. Then add 1. This got very poorly formatted. So you just you take the absolute value, invert the digits, and then add 1. Okay. Bacon's telling me with a sign bit. Is that like the same? Or I don't know. For example, signed integers can be negative, however, unsigned can represent larger values, making use of the bit usually reserved for the sign. Okay. But what about this whole 2's complement thing I just learned? Is that not accurate? This is what's used, for example, in x64 assembly. It's the same. Okay. So then how do I know? Because like this was the final answer, but how do I know that's not like the giant positive number that it could also be? Silo's back. Can't copy this. So then how do I know that 1111111 is -1 and not some giant positive number? There's no way to tell. There has to be preceding information. Okay. So you have to know beforehand. All right. Well, anyway, so I know at least how to. Okay, so a quad word was how many bits? How many bits is a quad word? How many bits in a quad word? 64 bits. That's 8 bytes. Okay. So if you put -1 in there, it'd be what? So you start with like, geez, I don't want to write this all out. 64 bits. If the first bit is 0, it's positive. If the first bit is 1, it's negative. But isn't that different from pointer types are so important because you need to know the type to know the size and how to represent the memory it points to. Okay. Okay, well, I can just reason about this, I guess, without writing it out. So what is test equal to after each of the commands listed previously? So we stick -1 in here. So like, what's a quad word? What's -1 in binary as a quad word? It's some giant. It's this. Whoa, it's all ones? Why is it all ones? Because it started out as 0, 0, 0, 0, 0, 0, 1. You take the absolute value, which is 0, 0, 0, 0, 0, 1. Then you'd flip everything. You'd get 1, 1, 1, 1, 1, 0. Oh, and then you add 1. And then you get 1, 1, 1, 1, 1. Oh, that does make sense. So it is all ones. Oh, perfect. Okay, so this is easy. You got all ones. You can't tell just by the first bit. It doesn't tell you if the first bit is used for integer denotation or if it's used for whole number out of the binary. It depends on the type. Sure, okay. Maybe useful to try implementing the code yourself and print test at the end to get some practice writing assembly yourself. It's not a bad idea. Let me just think about it for a second first. So this is all ones, right? Then you stick, wait. Okay, and then we stick, let me think about what it should be first, and then I'll move on to that. Byte. Wait, what is test? Oh yeah, test is that. Okay. You move 1 into the byte, but that depends on whether it's little endian or big endian, doesn't it? Yeah, it does. Because if we were, so is this assuming it's little endian? This is kind of interesting. So we have this. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 times, right? Or I should just take this. 1, 2, 3, 4, 5, 6, 7, 8. We have this. Now we're going to try to stick the number 1 byte of 1, which looks like this. 1, 2, 3, 4, 5, 6, 7, 1, right? Okay, we stick this. When you do Intel assembly, you have little endian by default. Okay, good to know. So this thing's actually stored backwards, but it doesn't really matter at this point yet because it's all ones, so you can't tell the difference. And then we take our number 1 and we stick it in the address of test, which, if I'm not wrong, would be on the little end of test. And so we'd get this, not that. This. How does that look, guys? That's my theory. This is for move, byte, test. 1. Yeah. And then looks good to you? Cool. Now, next, for my next trick, we do a word. A word is 2 bytes, right? So then a double 1 stored as a word looks like that, no? So then we just do kind of the same thing. Sweet, I never get to use Vim replace mode. That was fun. I think it would look like that. And then so on and so forth, right? Oops. This one would look like that. And then this one would look like this. Actually, same for all these, no? But we need to turn this into space, and turn this into space, and turn this into space, and turn this into space. Except for this isn't word now. This is a double word. And this is a quad word. This is what I'm thinking. Do I know base 16? You mean hex? Yes, in theory. I do know it. It's like all the 0x stuff, right? And then you go up to F. Yeah, could I have done this all representing it as hex? Well, this one would be right, because each byte. All right, I'll try just for you, Xylo. So the first each byte turns into two characters of hex, right? So like FF is 111111 or whatever. And then so we'd have FF, 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 and then we have 0, 1. Right? The second one becomes it's kind of the same thing, but we're just replacing, like, instead of 0, 0, 0, 0 with 1, 1, 1, 1, we're replacing 0, 0 with FF, right? So the next one becomes like becomes this. Next one becomes this and this and this and this and this and this, and the next one becomes all. Oh, we got one too many, don't we? Oops. This becomes all. Oops. All zeros. Oops. We gotta add in our spaces. Okay. Kind of like that. How's this? Could I get a grade? I think it's A plus. Oops. Where's plus? Right there. Yeah, that is a lot easier. I getcha. But this way, if it wasn't something as simple as like zeros and ones, like the number 0 and 1, I feel like this might help me visualize it better, especially if it wasn't quad words, right? So I don't know. I get what you're saying though. Fantastic. Look at that. I got it right. Okay. Cool. So I think we just did that. Let's see how one can encode operands in instructions. Okay. Immediately. So 1, immediately. An instruction is itself contained in memory. The operands in some form are its parts. Those parts have addresses of their own. Many instructions can contain the operand values themselves. This is the way to move a number 10 into RAX. Move RAX 10. Okay. Through a register, the instruction transfers RBX value into RX. Yep. So this is just like literally writing out the thing, and you could also write this in binary. You could also write this in hex. You can do whatever. This is moving the value that's in this register into there, or by direct memory addressing. And this is like using 10 as a pointer, if I'm not wrong. Like saying, okay, go look at our memory and find whatever is in like the 10th place, you know, or the 10th address, or and put it in here. We can also take the address from register. Same thing as this, but just taking the value in this register, instead of using it as a value, using it as a pointer to go get something from memory. We could use pre-computations. Okay, which is just instead using something that was defined like probably in the data section, right? And then the address inside this instruction was pre-computed because both base and offset are constants and control of compiler, and in control of compiler. Now it's just a number. Okay. So by the time this is actually compiled into like an executable, there's no math actually has to happen here, right? Is that what it's saying? Because like this is a compile time constant, like Zig. General knowledge about x86 and word. A word is supposed to be the size of a register in an architecture. In x86 32, it's supposed to be 32 bytes or 4 bytes, and in x86 64, it's 8 bytes. I remember reading something about that. Okay, NASM is an assembler, not a compiler. Okay. Thank you. Because x86 is so backward compatible and ancient, they stuck with word being the size of that, which is 2 bytes. So technically a word should be 8 bytes, right? Because that's 64 bits. But you're saying that for historical reasons, it's only 2 bytes. Am I right on that? Base indexed with scale and displacement. Most addressing modes are generalized by this mode. The address here is calculated based on the following components. Address equals base plus index times scale plus displacement. Whoa, that's a lot of math. Excuse me. That is correct. Cool. When expanding to 32-bit, they just stuck with it and called the register size a double word, and at 64-bit a quad word. If you then look at ARM or RISC architectures and check the word size, it will be 4 bytes in 32-bit and 8 bytes in 64-bit. Okay, cool. Base index with scale and displacement. Most addressing modes are generalized by this mode. The address here is calculated based on the following components. Address equals base plus index times scale plus displacement. I don't totally understand this. Base is either immediate or register. Okay. Scale could be immediate equal to 1, 2. Is this like the this thing here? Is this the scale? Maybe. Index is immediate or register, and displacement is always immediate. Okay. All right. So there's different addressing types. Yeah, it makes sense. Largely. A big picture. You can think about byte, word, etc. as about type specifiers. That's not correct English, I don't think. For instance, you can either push 1632 or 64-bit numbers into the stack. Instruction push 1 is unclear about how many bits wide the operand is. Okay. Okay, cool. In the same way, move word test 1 signifies that test is a word, yeah. Well, not test, but the value in memory at location test is a word. There's uninformation about number format encoded in push word 1. Oh, so you can do this too. That's cool. All right, calculating string length. This is a new section. How long have I been doing this? How long is this stream, guys? I can't see the duration. Why can't I see the duration? I need to like actually open my own stream. All right, looks like we're like 40 minutes in, no? Okay, cool, thank you. 40 minutes. Yeah. Well, I should just look at the time. 7:11. We started at 6:30. Yeah, I'll keep going. So 2.6, especially since Xylo's favorite example is incoming. Oh wait, no, maybe he guesses not. Oh no, he guesses not that Steven is here. Okay, cool. Or Stefan. Let's start by writing a function to calculate the length of a null terminated string. That does sound fun. As we do not have a routine to print something to standard output, the only way to output a value is to return it as an exit code through exit system call. Wait, what? Don't we have like the right syscall? Yeah, I know about this. Let's write an assembly program that mimics the false shell command. What? Oh, doesn't false just like return with a non-zero exit code? False. I actually don't know what specifically it is. It's 1. Okay. And then true is exits with 0, right? Yeah, okay. False. So we're gonna make our own false. False.asm. Here we go. We're gonna say global start section.text underscore start move RDI1 RDI1 move RAX 60. This means standard out. And am I using Linux kernel? This is on Linux. I'm on a Mac, but this is in a GitHub code space, which is running Ubuntu, right? So, is that what you meant? Right, 1 equals standard out, and then 60 equals right. Now we're going to syscall. So this is gonna just do false. Oh, sorry. That's not what we're doing. 60 is exit. My bad. 1 is the exit code. Kai is learning well. Thank you, Xylo. Yeah. Sorry, fix that. Let's try it. Let's try our false, our own homemade false. Where's my terminal? Over here. Okay. Nasm, do the Nasm dance. Nasm, here we go. Okay, Nasm, what do we call it? False. False. Okay, and then we need to link, no, false.o out false. Is that the command? Cool. Now we make our own homegrown false, and it's like that. And if we echo the exit code, it is verily 1. Okay, now we have everything needed to calculate string length. Cool. We're gonna make our own new guy here called a strlen.asm for finding the length of a string. How handy. Can I get rid of this window here? It's kind of cluttering. Okay. Here we go. Global start. All right, section data. Not this section data. Okay, and then we have a test string, which is db ab. Wait, now he's using double quotes. We were using single quotes, and now we're using double quotes. I'm confused. Maybe it doesn't matter. Maybe it means something different. I don't like not knowing which. Section dot text. In x64 is there a difference between single and double quotes? In NASM, they're used interchangeably. I should try instead of asking the LLM. Okay. Sterling. No, that's in C. Okay. I'll try it. Note. Try to differentiate. Or try with single quote. Alright, we have Sterling. Single is for single character, double is for string. Oh, that's what you're saying. No, that's C4. Yeah. That's also in Rust too, right? Alright, XOR, REX. Alright, he's got some nice comments. By our convention, first and the only argument is taken from RDI. REX will hold the string length. This just sticks 0 in REX, right? I know this. The same thing we do for like a nice zero exit code. If it is not 0 at first, its value will be totally random. Sure. Dot loop. So here's a label for loop. Byte RDI plus REX 0. All right, we don't understand this. All right, main loop starts here. Yes, you did tell me about XOR. Yeah, I think I get it. It's just like an exclusive OR, and since these are both exactly the same, it's going to be 0 for every single bit because they're going to be the same, right? And so you move that result value into the first argument, which is REX, and so we get 0 in REX. And it's like smaller or faster, or I think smaller on certain platforms, like this one, I think. So that's why we do it instead of move REX 1, right? Or sorry, 0. All right, so I was reading smaller by 2 bytes. Main loop starts here. Check if the current symbol is null terminator. Okay, this makes sense actually. We're checking if it's a null terminator because this is the null. This will be the null terminator. So we're checking against this guy. We're checking inside of RDI, which RDI is going to contain it's going to contain our string that we're checking against, right? Or the address to our string, which is why we need these brackets, because it's only a pointer, which is going to be something like this. And then we're offsetting it by our index, which is REX, which starts at 0, and then we're going to loop through. And then we're doing the byte. Why? Because we need the byte modifier since the left and right part of CMP should be of the same size. Right operand is immediate and holds no information about its size. Hence, we don't know how many bytes should be taken from memory and compared to 0. Jump if we found an alter. Okay, that's different. This makes sense because this is a byte, and so we need to tell this is a byte. So we're just checking against 1 byte, which is what a char is in ASCII, right? An ASCII char is just 1 byte. So that's why the byte is there. Definitely the most used bitwise operator. Okay, yeah. And then we're gonna jump if we found null terminator. What's the jump if equals, right? So jump if these two things are equal, then it'll set one of those like flags that kind of live in outer space. This thing checks the flag, and then if so, we jump to the end. So if we get to the end of the string, jump to the end. Otherwise, so this is after the jump. Like if we didn't get to the jump, here I'll comment. If this, oops, where's that guy? And this are equal, skip to end. Yeah, so we'll jump to the end label. But specifically, JE means the jump if equal, right? Because I know there's a bunch of like jump if not 0 and whatever. See, could I also do JZ? Because doesn't this thing actually like subtract them? That'd be interesting to try. Yep, I could. Okay, cool. And then otherwise, this is just like our loop counter increment or RAX, which just adds 1 to it. JNE is for jump not equal. So generally speaking, you add an N in the middle to make it not. That makes sense. Because it's JNZ, sorry, that's not a Z, JNZ, JNE, etc. Increment RAX. All right, and then jump, repeat. So this is like, in pseudocode, this looks like for something, right? Or like in nice syntax, it's like for something, if like, if like the value in memory, well, I don't know, if like the RDI, like index.rax is 0 or something, then the jump to the end is kind of like a break, and then otherwise we do like RAX ++ and then continue, right? That's basically what this is, kind of the same. Oh yeah, whoops. Thank you. I think these are equivalent. We'll leave this as a comment. Yeah, thank you. I changed it. That was just a mistake. All right, and then the point that we're jumping to if we end is down here. That's dot end. Asm has ++. This is my dialect of asm. It's called pseudo-asm. And it's called Kaya's assembly, chasm. And return. Return. So this just returns. Oh yeah, because the whole thing is still inside of this function, right? Cool. Now, the real starting point is down here. Start. We're gonna move RDI test string. All right, so this takes our test string, sticks its address in RDI. Cool. Then we're going to call our function. Now this is equivalent okay, I get what you're saying about break. So it's more like calling a function, or see, but calling a function wouldn't break. So it's more like a goto, no? It's like goto dot end, right? Because some languages have that. Is that better? Okay, so this is like saying like strlen with RDI is always the first argument by convention, right? So it's like RDI is test string. Is that? And then call move RDI, and then we move RDI into RAX. Why? Because we're gonna write it. Okay, cool. So then we take this, and then we move RAX to 60, and then we syscall. This says move RAX to RDI because we gonna print it, and this is the syscall code for print, and then, or write, I guess is what it's called, right? And then do it. Cool. Let's try it. First, let's read this. The important part, no. That's exit. Oh. See, I always get these confused. Oh, we're just sticking it in the exit code. We're sticking the length of the string in the exit code. Thank you. That is helpful. So to RDI to make it the exit code. And then syscall code for exit. I'm in PHP land. This is too much for me. I was in TypeScript land for many years until very recently, and this is still too much for me too. So it's fun though. I'm enjoying it a lot. All right, syscall code for exit, and then this will be like exit with RDI as exit code, which contains previous contents of RX, which is the length of string. I should just say that, which is the length of the string. I never did write PHP. I think I'm too young. I missed the PHP thing. Although I hear it's big again, or that it never died, something like that. There's kind of a big Laravel community, isn't there? The important part, and the only part we will leave, is the strlen function. Notice that strlen changes registers. So after performing call strlen, the registers can change their values. Okay. Strlen does not change RBX or any callie saved registers. Sure. Language wars begin. I'm not going to say anything against PHP because I've never written a single line of it. So, all right, let's try running this, and then we'll go to question 19. So, where's my little? Oh dear. Help. What is this? This is in English. Thank you. Okay. Uh-oh. It's all broken. It's all broken. Too old for too young for HP, but not for Anthem. That's funny. I'm 19. Actually, on Monday I turned 20. Turned 20 on Monday. Yeah, the terminal gods are angry. I'm going to what am I gonna do? I'm gonna do this. Wait, how do I get out of this? Control / Control N. Thanks, guys. All right, now I'm escaped. Then I'm gonna Control Q. Wait, hold on. Control. Hold on. Control W. Q. Whoo, there we go. And then back in. There's my false object file. I'm not sure how he got there. All right, now I'm going to. Is that your kid? No, I do not have children. That is the brother or son, depending on who you're talking about, of some friends. And then where was I? Oh yeah, so we were trying to execute it, and then my terminal got mad. Okay, terminal. Oh, thank goodness. Yeah, he's like 4 years old, so and that picture was taken like 2 years ago, so that'd be bad. Let's. Where was I? Oh yeah. Okay, so NASM -o elf -f elf 64. That was weird. Maybe I should change that. -f elf 64. What do we do here? Oh yeah. Okay. What did I call it? Strlen, right? -asm -o strlen.o. It assembled, not compiled. It assembled, and then we link it by saying link strlen.o and then -o strlen. Now, moment of truth. Oh yeah, it stuck it in the exit code. So we're gonna do this. 6. Now I have no idea if that's right. So let's go check our was it strlen.asm? Sure enough, we got 1, 2, 3, 4, 5, 6. Wow, it actually really works. All right, now I promised somebody that I was gonna try it with single quotes. So here he goes. Let's try it with single quotes. So same. Oh dear, bad things are happening again. Can I don't like how this is. Oops, okay. I gotta quit out of there and then do that. Okay. Now, over here, I'm going to say Nazem again. Well, I can just do the same thing. This guy, and then link him again, and then do that again. Okay. And now, it would appear as if single and double quotes are interchangeable. Excuse me. Double quotes make my tree sitter happier, because tree sitter always seems to be a bit confused in my Nazem files. But try it with \n new line. What, like in here? Is that even illegal? Is it even legal in assembly? I mean, I'll try it. Yeah, the quotes make no difference. Thanks. 8. Yeah. So it would appear as if it's counting this as a / and then an n. So like 1, 2, 3, 4, 5, 6, 7, 8, right? So that doesn't actually work, I think. That was a fun example. All right, can you spot a bug or two in this listing, which is assuming, yeah, it's this. Wait, right? 250? No. Oh, this is 214. So it's the next one. Can you spot a listing, bug or two in this? When will they occur? Alternative version. Let's find out what's different. Yes, 2 characters instead of 1, I think. I mean, that's what it seemed like it was saying. Because I got 8 instead of, I would have liked to see 7 if a \n worked. Test string. Yeah, okay, that's all the same. Stirlen, loop, we loop. Let's switch over here. Compare, we compare the things together. Except we're using R13 now instead of RAX. Wait, right? So what's different here? We're saying already. This is the same. Okay, there's a few bugs in here. I think I'm seeing. We're using R13 without zeroing it out first, like we did here with RAX. Okay, and that is gonna be bad because anything could be in there, I think, right? And so anything could be in there. So like this index doesn't make any sense necessarily, unless it happened to by coincidence be 0, then it might work. But it could be anything, and so we're indexing by the wrong. We're offsetting our index by some random number. I think that's right. Then any other errors? I mean, we're mutating, we're changing R13. I don't know if that's one of the ones we're not supposed to change. What was that? I had that handy table. Where's my browser? Oh, who's my browser? You guys can't see this. Now you can see this. R13. Sure enough, save before using will not be changed when calling a function, and we're not doing that. We are changing it. So if this guy by convention, R13 shouldn't be changed inside of a function, and we're changing it right here, right? So that's another error. So that's two, a bug or two. I think I found two. Correct me if I'm wrong, but I think that's two bugs. One, that we're not zeroing this out when we start. Two, that we're mutating it inside of a function, which is no bueno. All right, how are we doing on time? 7:36. I mean, I technically have till 8:30, but I don't really want to go that whole time. I'll go a little longer. Well, how long is this section? Oh, it's short. All right, we'll at least do this. Assignment. Oh, it's an assignment. So maybe it's not so short. Oh dear. Sorry if this is loud when I'm moving my microphone. Move my desk. Okay. Before we start doing anything cool looking, what do you mean? This isn't cool looking? We are going to ensure we don't have to code the same basic routines over and over again. As for now, that makes sense. We do not have anything. Even getting keyboard input is a pain. So let's build a small library for basic input-output functions. First, you have to read, oh dear, Intel docs. For the following instructions, remember they are all described in detail in the second volume. I know about this one. I know about these ones. Maybe I don't. Is JMP just like JMP just an unconditional jump? How long will today's stream be? I mean, it's gonna be until I run out of steam, and that is going to happen, I guarantee you, before 8:30, because 8:30 is when I transition over to music practice time. JMP is so yeah. Question: is JMP an unconditional jump? Because like JE is like jump if equal, JZ is J if zero, jump if zero, but this is just jump. What time is it now? Oh yeah, you guys aren't in the same time zone, are you? It's 7:37 for me. 7:38 now. This compares things by subtracting them. Jump if not parity. Oh. Wait, then why is it M? If it's not. You should download volume 2. I think I did download it. Is it this? Where'd it go? Does it look like this? Look, I'm in volume 2A. See? Right here. Is this the right document? Yes, I'm in Eastern Standard Time. I'm in Ohio. Alright, I know what that means, I know what that means, I know what that means. I know what that means. I know what that means, I'm assuming that just is decrement. I know what that is, I know what that is, I know what that is, I know what that is. I have no idea what that is and no idea what that is. But I remember seeing something like that. See, what's the difference between idiv and div? Neg? Negate? Negative? I don't know. We'll look that up. Jump if above. Okay. Call, return, push, pop. Yeah. Okay, so I generally know what these are. I don't know what the imul and the idiv. Unsigned comparison. Greater jumps if. RX. Yeah. Okay. These commands are core to us, and you should know them well. As you might have noticed, Intel 64 supports thousands. Seriously, thousands. Of course, there's no need for us to dive there. Using system calls together with instructions listed earlier will get us pretty much anywhere. Oh, cool. So I don't have to memorize thousands. You also have to read docs for the read system call. Oh, okay. Its code is 0. Otherwise, it is similar to write. What was write? Write was 1, wasn't it? So read is 0. Refer to the appendix C in case of difficulties. UTC minus 4? I thought it was minus 5. What is EST relative to, what is it, GMC, the normal one? No, GMT, GMC, GMT. What is it? Normal time? Green meridian something? Sorry, what's green meridian time or something? GMT, sorry. I meant GMC is the car. That's what it is. Okay, GMT. Yeah. Oh, Greenwich, not Green Meridian. Gee whiz. Um, time zone used as a reference point. Yeah. Sorry, I meant. Oh yeah, 5 hours. Sorry. Yeah, so it's 5. It's 5. Oh, but you know what? There is daylight savings time. Yeah. Sorry. Okay. But we're not in that right now, or maybe we are in that right now. I forget. Yeah, UTC. Before we start doing anything cool, yeah, okay. These commands are core to us, and you should know them well. As you might have noticed, yeah, wait, I already read that. All right, edit lib.inc and provide, what's lib.inc? Where did that come from? Provide definitions for the functions instead of the stubs. Refer to table 2.2 for required function semantics. We do recommend implementing them in the given order because sometimes you will be able to reuse your code by calling functions you have already written. Xylo needs to leave. All right. Bye, Xylo. Thanks for all the help. Thank you for the welcome. I'm going to upload this afterwards, so obviously you can watch the rest of it. I'm not going to go too much longer. Where are these, like... Where are these... Thank you. Yeah, see you on Discord. Well, it keeps referencing like lib.inc and oh, wasn't there like a GitHub repo? Maybe that's what this is on. GitHub, well, like it's like low. Here, I can pull this up here. Low level programming GitHub. University. That's not right. Source code. Assignments. Here we go. Oh, this is it. Stud. Teacher. What's teacher? Lib.inc. Oh, is that the answer? That's the answer. Don't look. Stud. Oh, stud is for student. Oh, perfect. This is great. Take this. And Python. Oh no. I don't even know how to run a Python script. Oh, it's got a shebang. Assuming I have Python installed, I mean. Term color. Maybe I just like see, is there a way? I've always wondered, is there a way in GitHub to wait. Is there a way in GitHub to download like one subdirectory? Because that'd be the coolest thing. Alright. Well, I'll just copy this in. So I'm gonna make a new like folder over here. Well, let me bring this down here so I can see your guys' chat again. Okay. I'm gonna make a new, I'll make something called like assignments or something. I'll make everything else be in like a scratch pad, not a file. A scratch pad. You can do it? How? Teach me. Scratch pad will contain all of this, and we'll put that all in there. Okay. Assignments will contain, what was the first one called? You could do it with Git. Oh, is there a way with Git? Okay, I'll look into that, but I probably don't have. Probably wouldn't be the wisest thing to try to figure that out on stream. when it's just 3 files. So we have assignments. What's this one called? It's called IO library. 1 underscore IO lib. All right. I'm gonna copy over these files. So we got a lib.inc, and we're gonna copy it. Oh, this is it. Could somebody tell me why it's called .inc instead of .asm? Can I just change that? Is that bad? Yes. All right, and then we have this test file, which is called test.py. Look at this beautiful Python. All right, now we've got that, and then there's one other one. I don't know why I need it though. Term color.pyc. I have no idea what that means. Term color.pyc. Just in case, I'll stick it in here. Is that it? Is that it? I clicked copy raw, and this is what I got. I guess that's it. All right. So I may not finish this today. Inclusively means it was supposed to be included. Okay. But I'm not including this anyway, right? It's all within this one file. Yeah, like a header file in C. Okay. Here's what each one needs to do. I guess we should try the test thing maybe. Sorry, CD assignments 1 test. Permission denied. Chmod plus X. Okay, now let's try it. That might be because I renamed the assembly file. How do I get out of here again? I think I just click out of here. Thank you. Can we find ink? Oh yeah. Oh, it is being included. But is it required to be included? Like, do I need the ink to include it? Probably not, right? Asm. Because I'm not even getting syntax highlighting. Oops. If I don't call this asm. And I'll take syntax highlighting over semantics. Alright, that's all of them. Let's try that again. Okay, cool, thank you. No, so try the directory. Uh-oh. That's not a very helpful error. It's not even telling me what it's trying to find. Oh, it's saying that user bin Python isn't such a thing. Oh, I get it. So I don't have Python installed. Where's P? Where's P? Here we go. P. Where's Py? Python. I got Python 3. Will that do the trick? I don't know anything about Python. Uh-oh. Let's try that. Oh, yeah, that's a good idea. Just which Python. Aha. Okay. Now, over here in this guy, we need to change the shebang to be this. Uh-oh. Uh-oh. I lost it. All right, here we go. It's home code space dot python current bin python. Cool. And then over here, I'm going to try that again. Okay, I'm going to do what? What was I gonna do? Oh yeah, do this. Okay, now I can read it. Invalid escape sequence \d. Okay, it's a Python2 script. Alright, do I have python3 installed and it's a Python2 script? Is that the problem? Python -s version. Sure enough, I've got Python3 installed. And you guys are telling me it's a Python2 script. So, what do I do? What do I do? Install Python2? I would need Python2. It's kind of annoying that I need to get Python just to run my assembly. Alright, well, how do we install Python2? How would I know that? Yeah, no, it's not there. Python2 isn't a thing. But is there a way to, like, I don't know, sudo apt install python @2 or something? I don't know. Well, if you notice, when I opened the GitHub repository, all the files were like 7 or 8 years old, so that might have to do with why it's not Python3. Yeah, okay. Install. Here, I'll pull this up so you guys can see it. Let me make. Yeah, I'm gonna pull this into a new browser window. There we go. Actually, I don't want like a tiny window. There we go. New browser window. Okay. Install Python2 on Linux. Hey, right here. DNF. But I think I have apt. Let's try it. Cool. Now if I say which Python2, ooh, look at that. Hey, Zylo's back. Yeah. Yeah, I got it. Okay. So I have it. Now I need to go and change my, is user bin python2. So I need to change the shebang. User bin python2. All right, now I'm going to, it's gonna work. What is it? Test. Term color, import colored. Bad magic number. I've got a bad magic number. That's disheartening. So that sounds like it's talking about this weird term color thing I copied over. which looks like this. Not the prettiest file, but we know you hate Python. You've made that very clear. What is this term color thing? Why do I need this? Could I just get rid of it? Probably not. It should not look like that. All right, that makes sense. Where was it? It was like a low level programming. See, maybe I'll just get this all set up, like the test working, and then stop the stream, and then next stream try to actually start working on the assignment, because that sounds like a lot of fun. Also, I forgot to mention, tomorrow I'm going backpacking. Gonna be gone Saturday, Sunday, Monday, Tuesday. So next stream will probably be Wednesday. Low programming GitHub. Source code. Assignments. IO library. Stud. Term color. View raw, like downloads that. Because I already had one. Okay. So now, term color. Okay. So let me like open up a new window over here. So CD like desktop is where I went. Fight cat. Term color. This is sure enough different. Let's try this. I've got a plan. Clone the repo. Should I just clone the repo? Okay, I could just clone the repo. That's not a bad idea. That sounds like it would save me some grief. In that case, Scratchpad will go here. Here, source will be like the source of the thing. That's what we'll clone. I guess I'll get that when I clone. No. Let's. Oh dear, this is annoying. Let's. What was I gonna say? Let's. Okay, so git clone. Sorry, where'd the this guy go? I want to clone. All right, gotta go, Bacon. See you, Bacon. Bye, Bacon. You've been helpful. Thank you. See you on Discord. Code. Copy. Git clone this into. I'm in the wrong place. There we go. Okay. Git clone this into source. Now we have source. Okay, and then should be done fairly shortly, I'm hoping, with this. All right, so then I changed a few things though, because like I'd made, oh yeah, so it's like assignments, this guy, student. This wasn't giving me any syntax highlighting. Oh dear. This wasn't giving me any syntax highlighting, and so I changed it to ASM. But then when I do that, I need to go into here and find all the places where it's like .inc, because I need to switch that to ASM. And then do the same thing here, same thing here, same thing here, same thing here, same thing here. True assembly programmers use Notepad. Sorry. All right, that's all of them. Ink is no more, or .inc is no more. Okay. Save that. Get rid of that. And then jump over here. This is much more substantial now. You're right about it not supposed to be looking like that other thing. And then what was my next thing? Oh yeah, so I need to change. Yeah, shebang. Thank you. It's user. It is this, but it's python2, right? So, right? Is that what it was? which python2, yeah, user bin python2. All right, get out of there. User bin python2. Sure enough, is what I have. Moment of truth. Here we go. Where do I go? A cd source assignments 1, and then cd stud. All right, test.py. Ooh. That's what I want, right? Wait, testing string length on that. String length compiled, it compiled, and it failed. Sweet, okay, that's exactly what I wanted. All right, I'm gonna stop there because that's like a perfect, it'll leave me, so like next Wednesday. Sorry, it's gonna be a little while, but I'll be set up for success, right? Assembled, not compiled. Look, it says compiled right here. Can you argue against this guy? All right, I'm gonna stop the stream. Thanks everybody for the help. That was fun and learned a bunch. So until next time.